Let's talk about transformations, specifically for graphs. So let's say we have y equals x squared as a basic example. Let's go ahead and graph that. And it's going to look something like this. It's a parabola that opens upward. Now I do want to point out, please make sure you do know how y equals x squared looks. You will need that for calculus. But we will talk more about polynomials in general and how to graph them a little bit later. So don't worry too much about it just yet. So for shifting, what if I take that graph and then I'm going to say y equals x squared for the next one, but instead I'm going to say minus 1. Just at the very end of this thing, I'm going to shift it down. Well, I just go down. So I just go down 1. So now at this point, every point on the graph will get moved down 1. So it doesn't actually change the shape of the graph at all. It looks exactly the same, except it's just been moved down 1. Another thing we could do is we could shift on left and right. Oh, before I go into that, I should point out this minus 1 moves it down, but a plus 1 would move it up. So like if I did a plus 1, it'd look like this. So you just move up and down however that ending thing is. Now let's go ahead and take a look at what if I did y equals x minus 2 squared minus 1. You'll notice I still shifted down 1 here, but now I'm doing an x minus 2. Now, this is backwards from what most people think. So this minus 2 actually moves to the right. So I'm going to take this red graph that I had before, and I'm going to move it to the right 2. The minus sign means right. If we did an x plus 2, that's what would move it to the left. So that's how you shift left and right, is inside the parentheses. I often say that things inside parentheses are opposite what you think they are. It's a kind of a general rule that applies in most of math, but it's certainly not a overarching always rule. So x minus 2 squared then is going to take this point here that we got from the red graph that shifted it down, and now I'm going to move it to the right. So this point right here is going to be 2 over. So we went down and over 2 is what shifting did. And then otherwise, just like before, this graph isn't any different. It has the exact same shape as before. Nothing is different except just where it moved. The vertex right there has moved over, and along with every other point on the graph. There's one last thing that we can transform with, is what if I did like an a value? So I have 3 times that x minus 2 squared minus 1. So in this case, it looks exactly like the green graph, but this 3 here is going to just change it vertically. It's going to make the whole thing steeper. So it's not going to change where the vertex is, but it's going to be just a little steeper. It's going to look like this. Now, there are several versions of what this a value could be. Here, like say if we had a negative 3, then we would make it like this. Or maybe we had it be a negative 1/3. Well, if it's less than 1, it's going to expand it out like this. So there are a few different versions of what the a value can do, but that's generic what it does in general. Now, one thing I want to point out that I don't think gets emphasized enough when you learn these things initially is what I have been talking about is not unique to quadratics. Not at all. Some people would tell you, okay, y equals a times x minus h squared plus k. That is the generic form. It involves everything we've talked about. K is the up and down shift. H is the left and right shift. And A is the kind of like the slope. It gives you the steepness. And while that is true, any function I give you would be basically the same thing. For example, let's take this graph of f of x. It's some random who knows what graph. It's certainly not a quadratic. But if I wanted to say what is the graph of f of x minus 1 plus 3 look like? Well, this is the shifting of x, and this is the k. So basically, what this graph is going to do is it's going to move everything to the right 1, and it's going to move everything up 3. So this new graph let's start with this point. It's going to move from that point there. It's going to move to the right 1. So I guess it started off over here and moves over here, say, wherever that 1 is, and then up 3. So that point is right here. But otherwise, everything's the same. Goes through, looks the same. It's just been moved over to the right 1 and up 3. Any function at all follows these exact same transformations. So in algebra, they teach you a lot of transformations for each of these graphs, but it's all the same stuff. What you learn for one is the same exact thing for the others. There just might be different notation and things, but pretty much it's all the same thing.